Right, and then this with example 4, it says, does the equation f of x equals x squared minus 2x have an inverse? And look at this, they're giving us a specification, so I'm thinking it probably does, but just in case we need to graph it. So let me just kind of draw ourselves just a basic graph for all those x values greater than or equal to 1. So starting at 1, 1 minus 2 is negative 1. If I plug in 2, be 4 minus 4, which is 0. If I plug in 3, it would be 9 minus 6, which is 3. And it's looking like we're definitely going to get it. If I try one more, 4. 4 squared is 16. 16 minus 8 is 8. So it's going to be kind of up there. So it looks like we're kind of doing a half thing right there. Okay, that's definitely passing the horizontal line test. So yes, I would say let's go for it. Now, before we go on, because I graphed this, the domain basically is all those x values greater than or equal to 1. That's what it tells me. Let's look at the range though. The range, the lowest it ever gets to is when I plug in 1. So 1 squared minus 2 was negative 1. So it's all those y values greater than or equal to negative 1. And this is going to be special to us because the range for the original function is the domain for the inverse function. So we need to pay attention to that. All right, let's get the inverse function. We're going to start out with y is equal to x squared minus 2x, and we'll swap it around. So now x is equal to y squared minus 2y. Well, how can I get y by itself when I have have it in two different spots? Is it really going to matter if I factor it off? You're like, ooh, you can factor it, but still, it's in two spots. How are you going to get it to be the same? Do you remember back just a few lessons in the past where we did this whole thing called completing the square? You've got to complete the square. So let's go here to that number that's attached. Just come over here to do our side work. The number that's attached to your first power variable, you always divide by 2 and square it. So negative 1 squared is 1. So we're going to add 1 to both sides. So y squared minus 2y plus 1. And let's factor this. See, y minus 1 squared. I guess I really don't have to have the parentheses there on that left side, but okay. Now we kind of brought the y, instead of having it into two parts, we now have it in just one isolated area. It's being squared, so let's take the square root of it. Okay, so the square root of x plus 1 is equal to y minus 1 now, because the square and the square root cancel each other out. Let's move the 1 over. So the square root of x plus 1, remember that's all underneath the radical, so this other plus 1 is going to stay outside. Make sure I write some emphasis for that. Or we can do it like this. So f inverse of x, which is the y, is equal to the square root of x plus 1 plus 1, and then we have to tack on now our domain for this one, saying that x is greater than or equal to negative 1. Remember, I get that from here. Just obviously replacing the y's with x. And there's my function. And that looks good because what this is, let's graph this. It's a square root graph that would normally we tentatively draw it, come like that. But we're going to move it left 1 and up 1. So it's going to go left 1 and up 1. So it's going to now be centered there and kind of curve like that. And doesn't that look like something that can reflect each other across that line y equals x? So it's very good that we took part of a parabola and we got a radical to be its inverse. Okay. With example 5 and the next ones, we're basically going to be doing almost exactly what I've been doing in the other ones. It's just they're making us for sure look at the graph 100%. But we can go ahead and assume that f of x, the original one they give us, will have an inverse. That's the only difference here. We're going to assume, otherwise they wouldn't give it to us. So we're going to definitely assume it, and then we're going to graph it. Okay. So let's start out. I'm going to go ahead and just do the graph. And if you kind of want to, let me show you just some unique trait about this. If we look to the original function, f of x, what's the smallest value of x that I can still plug in and take the square root? I can't plug in negative 3, because negative 3 plus 2 is negative 1. You can't take a square root. So I'm going to start here at negative 2. So negative 2 plus 2 is 0, and the square root of 0 plus 3 would be 3. If I plug in -1, -1 plus 2 is 1. The square root of 1 is 1, so 3 and 1 is 4. Think of another number I can take a square root of. Let's say I can do 4, so if I plug in +2, 2 plus 2 is 4, the square root of 4 is 2, and 3 is 5, and so on and so forth. Okay, now if I wanted to, I could technically go ahead and draw my next graph for my inverse function, because the inverse function, all you have to do is swap the x's and y's. So I should get the point 3, -2, 4, -1, 5, 2. So what we're going to do is try to get this by hand using the equation and see if we can actually get those coordinates to come out. So this would be the t-chart for our inverse graph, and then over here this is the t-chart for our regular function. Okay, so let me go ahead and graph that. So there's -2, 3, -1, 4, 2, 5. So again, typical of a square root graph, very slow rising, just like that. Okay, so let's see, by the time I draw this, see we got 3, -2, 4, -1, and then it would be 5 up at 2. So it'd be curving up like that. So eventually they're going to meet and cross over that line y equals x, but let's see if we can get it through the equation. All right, now I'm going to have in this time instead of y equals, I'll go x is equal to 3 plus the square root of y plus 2. So x minus 3 is equal to the square root of y plus 2. Let's get rid of that square root sign, so let's square both sides. Okay, so squaring x minus 3, I've got a base that has more than one term, so I've got to make sure I square it out properly. X squared minus 6x plus 9 is equal to y plus 2. And then lastly, just getting the y all by itself, we get x squared minus 6x, 9 minus 2 is 7, equals y, or if we write it in inverse notation, we can get x squared minus 6x plus 7. And I bet you all are getting practice with this. You already know that because this represents a full parabola and that purple line is only half of a parabola, we've got to narrow it down to. And what we're going to narrow it down to was the range from the original function. So let's go back to the original function for 2 seconds. Let's focus on this blue line. The domain for this blue line, the furthest left it got was -2. So it's all those x values greater than -2. And then the range for all y values larger than, it looks like, positive. Let's see, what was the highest y value we got? On my graph, it kind of looks like 2.5, but it is actually 3 from our t-chart. So look at that, from 3. Okay, so there's that main one we want right there, because the range of our original function is the domain for our inverse function. So the domain is all the x values greater than 3. And look, isn't that pretty much what that graph looks like? All those x values from 3 and to the right. So there's our inverse function, and there's a graph that represents both of them right there. Okay, let's try this again, example 6. I want to start this one out again. We're going to draw the graph. Let me get some t-charts going on in here. So here's my original function, x and y. It's telling me just this time I don't have to think about, ooh, what's that x value I can start with, or what can I work with. This one, it's already given it to me. I can only start with 3 and go beyond. Okay, so if I plug in 3 minus 3 is 0, then minus 6. If I plug in 4 minus 3 is 1, and 1 minus 6 is -5. 5 minus 3 is 2, 2 squared is 4, so 4 minus 6 is -2, and let's just try one more. 6 minus 3 is 3, 3 squared is 9, 9 minus 6 is 3. Okay, so let me draw this graph. Okay. And again, if we want to list this out just real quick, the domain here has already told us x was greater than or equal to 3. Now the range, let's see if we can get that. It looks like it's going to be y is greater than or equal to -6. Because this is where the domain starts, that's where the range is going to start. And it looks like the smallest it is -6, and it keeps getting larger and larger and larger. Okay. So at 3, we're down at -6. Probably need to do a better job of drawing those lines to scale, but oh well, for right now. 4 is -5. 5 is -2. And 6 is 3. So we're getting a parabola, part of a parabola, which is great. So now let's go up there and let's cheat. Let's find our inverse one by just swapping the x and y values. So -6, -5, -2, 3. And our x's, our y's here, now we're the x's. So in other words, the domain here is x is greater than or equal to -6, and the range is y is greater than or equal to 3. Let's draw the graph. So at -6, 1, 2, 3, 4, 5, 6, we were up at 3. At -5, we're up at 4. Yeah, I need to do a better job of that, but -2 is 5. And 1, 2, 3 is up at 6. So you can definitely see it's another half parabola, and they're eventually going to cross and reflect each other along that line y equals x. Okay, let's get the equation for it. So now x is equal to y minus 3 squared minus 6. Let's move that 6 over. And then we're going to take the square root of both sides, so that way we can get into that y right there. So x plus 6 is equal to y minus 3. Make sure I keep that x plus 6 in the square root sign. And let's move that 3 over. And then keeping it out of that square root sign, because the only thing in there is just that x plus 6. All right, so f inverse of x is going to be the square root of x plus 6 and then plus 3. And specifically, if I pull this off, x is greater than or equal to -6. And if I wanted to, let's even just look right here. It's a square root graph that has been shifted left 6 and up 3. So a square root graph starts at the origin. If I moved it left 6 and up 3, looks like we've got the exact same thing. So it's really good to check it out like that. But here's the answer for this last function and how to get its inverse and everything.